Hello guys, this is Ravi Rajput. Welcome to my YouTube channel Next Gen Neuron. So today we will demonstrate the CNN application code-wise, right? So how does it look like in code? So I have developed a small application using CNN, convolutional neural networks. So basically, I had already described the mechanism of convolutional neural networks, how CNN works, right? So if you want to learn about that, so please refer to the other video in my YouTube channel. So this is the extension of the previous video, like how CNN looks like code-wise, right? So what I have tried to do here, this is an example, a very simple example of CNN, which is classifying between two animals. No, not two animals. Sorry, classifying between animal and building. It's a simplified version because animal and building seems different, right? So it's easy for small model to recognize. So this application shows how model identifies between animal and building image, right? So what I have done, so in order to prepare the data, so in CNN models, next gen neuron, so I have created two directories. So one is the train data and second is a test data. So train data is having the sample images on which we will train our CNN model, right? So I have kept in two separate folders. One is animal, another is building. So in animals, I have kept a few animal images which we will use to train the model. How does animal look like, right? So if you remember my previous video for CNN or how CNN works, so in which I had explained like CNN extracts the basic features out of the image and learn the patterns from it. Like it will learn from these images patterns, like if the image is containing some ear-like structure pattern or tail-like structure, that should be the image of an animal, or if it is pretty straightforward like a block, it should be the image of a building, right? So this will happen during the training of the model. So from this image set, or these set of images will be used to train how animal looks like, and the second set of images will be used to train how building looks like. So from these images the model will learn how building looks like, or identify the building, right? So this is our training data. And another interesting part is, yeah, this is a training data, and the second set is a testing data. So what we'll do, we'll train our model and then we will test our model. Okay, so training, I showed you the data set, and this is a wider data set for testing the model. So basically the idea behind the test images are those images are different from what were used during the training. That's why it is said as a testing data, right? So testing data should be which is not recognized by the model, or not ever seen by the model, but model will try to identify based on what it has learned. So this is a testing data set for animal. Similarly, this is a testing data set for building. Some new images for building which model is never supposed to look at or never seen before, right? So if you see here, just a very quick thing. So if you see here in the testing data set for building, if you see, I have kept an image of horse as well. So this is just to confuse the model. We'll see if model is going through the building data, will it be able to identify there is an animal sitting also. So this is just to confuse it, and let's see how it works. Okay, so code wise what I have done, so I have used the definitely the Python programming language and some yeah, deep learning frameworks such as Keras, TensorFlow, and PyTorch. So here I have used only the Keras, but definitely I'll be demonstrating some more applications using PyTorch and TensorFlow frameworks as well. So yeah, so Keras is it's an enhanced version of TensorFlow, which is pretty user friendly. I have used it here, so it's easy to understand. So what I have done as a first part, I have imported all the required libraries here. So if you see the glob, CV2 for images, NumPy is a famous library in Python for handling arrays, right? So definitely to understand this code, the first prerequisite is to be familiar with Python programming language. Yeah. TensorFlow I have imported. I had described about the TensorFlow which was developed by Google for deep learning applications. And similarly Keras. So Keras, I have imported couple of modules from Keras. So one is layers and another one is models. Layers, you can if you have seen my first video, how CNN works, right? So in that I have explained about multiple layers. Those are the part of any neural network architecture, right? So those layers are being imported from Keras. So we will leverage the CNN Con 2D or convolutional layer, max pooling layer out of it, right? And another interesting part is in the Keras model selection, I have imported the module for test train split. So as I had mentioned before, like the test train split is, yeah, the train data set is needed to train the model. So what test train split does, it basically splits the training data set in two parts. Like usually we do the keep the ratio of 80-20. So 80% of the images will be used for training the model, and 20% out of it will be used to test the model. So don't get confused with the testing data set, that is separate. But this separation happens within the training data set. So 100% of training data set will be divided in 80-20 ratio. 80% of training data set we will use for training the model, and 20% of training data set we will use to evaluate the model at the same time. Once the training is finished, right, then it will generate some accuracy and loss graph. So we'll see how it goes, right, or how it happens. So just for now, remember about the train test split, and couple of more custom modules. These modules, these functions I had written for augmenting the images and evaluating the model, which is not pretty much necessary at this point of time. I'll give you the idea of augmenting images in last, what it happens, what is augmenting of images. Yeah, so next part is, like, if you see, I had this is an image path where I'm referring the images from for training data, right? Forget about this one. This is some different thing. Yeah, I had kept the pixels of image. So whatever the image, it's going to be standardized or normalized, right? It's going to be standardized to 224 by 224 image, right? So every image is going to be consistent for the model. Epochs 12, what is the concept of epochs means the number of iterations. So the learning happens throughout the iterations, multiple iterations, right? So the first epoch, like first iteration, it will go through the training data, right? Will learn in the entire data. Once it is done, it will check accuracy, right? So how much accuracy is there after going through the first iteration. So there may be some accuracy like 70% or whatever. Now it will start another round. It will go through the again. It will go through again through it will go again through that test data, right? So in the second iteration, the accuracy is supposed to be a little higher, right? So it will go through again. It will learn again the same patterns. So it will perform better. So similarly, third round happens, which is a third iteration or third epoch. It will go through the entire data again, will again learn some more patterns which it might have missed in the second iteration, right? So the accuracy will be accuracy will be more than the previous one, and so on. So that's how it goes during the training, right? So these are the number of epochs. So 12 iterations. The training will be running for 12 iterations, or 12 rounds. And going ahead, so this is a method for reading the image folder. So if you see, uh, it is reading the entire animal building data directory, getting all the folders in it. So currently we are having two folders, animal and building there, and it's reading it. This is the main part for CNN. So what it comes, so random seed is 42. Basically, that is something which is used for the consistent record. So I'll describe later what that random seed is. It's about, providing the consistency in the training. So you are running the training two times, three times, four times, so it will not give you the different results. It will be consistent, right? So that's what random seed is about. Train X, test X, train Y, test Y. So I have used a train test split function here, where I'm passing X and Y, the part of the data set. right? The images and its labels. So x means image, and y is its label. Like it's an image of animal, and y is its name animal, right? So what it will happen, it will check the image, right? If it's animal, it will learn based on the y, what is the label. It's an animal label, right? So every image will be tagged with its label. Otherwise, how model will know what classes it is going to identify into, right? So x is the image and y is the label of the image. Okay, so it will be processed to train test a split function. And this function will split the training data in two parts. Like point 2 means 80% data will be used for training, and 20% of data will be used for testing from the training data. Okay, so yeah, so another further processing, train x, text x, I have converted those as array. So as I mentioned, like in, if you see my previous video, all the images are processed as a pixel grid, right? So that's how it is happening. Here I am, after dividing by 225, I am normalizing the image. And this is also one of the standard process in CNN, like processing the images. We need to normalize those. Here is a part image augmentation. So this is something which is optional. I'll tell you what image augmentation is about. So for example, you have a small data set like 10 or 20 images, right? Which you are going to use for training. So if there are less number of images, model will not be able to learn better, because to anyone, like either for model or for human to learn better, they need more data, more material, more books. Yeah, so overall more material, so then they will learn better. So the similar stories with uh, model as well. So model needs more data if you want more accuracy, right? So in a case, if you are having a less data like 10 or 15 images, you can perform image augmentation. So what it will do, it will flip the images from multiple angle and generate a new image. So if you have processed the cat having its face in front, right? So image augmentation will generate four different version of that image, like a cat sitting in having its face in right direction. One version will be a cat sitting its face in the left direction and from a different angle, right? So each version can have multiple variants of it. So for example, you have 10 images. After image augmentation, it will become 10 into 4 40 images in different versions. So by this, you increase your data set, the volume of your data. So processing more images will give more accuracy to the model. So this is completely optional. If you have a large data set, you don't need to go through image augmentation, so it's on you. Okay, so another yeah, this is the main thing, right? CNN layers, as I had mentioned. So the first one I had mentioned, the convolution layer, where which is the first part of the CNN, where the image goes and the filter slides over the images, like 2 by 2 filter or 3 by 3 filter, which slides over the image grid or pixel grid and extracts out some basic features after magnifying those, right? So this is happening here. Max pooling I had applied. Max pooling means again, like enhancing the image, like from the image pixel, remove everything and find the maximum value of the image, extract that particular information from it. So yeah, to know more, refer to my previous video for what is convolutional neural networks. Here, yeah, so I have done again, like uh, another stack of layers for the same pair, like convolutional as well as max pooling. I had added more. So this is, so the much you increase the layers in your model, right? So the much model will be accurate, but definitely it will be more time consuming or resource consuming, right? So it's on you. So you just need to be more conscious, like, or you just need to be careful how much layers you are applying. You don't need to go and put a lot many layers in a first go. You just need to tweak them based on your need, right? And the optimization. So I, for now, I have put the two pairs of these convolutional and max pooling layers. So and after that, this is a flatten layer. As I had mentioned, this is a main layer where all the image grids, or the portion of the images are being combined together to form the entire image, right? So uh, where each neuron from the previous layer is connected uh, to each neuron of the next layer, yeah, or of this flattened layer, right? And after that we are applying the softmax function of softmax function. This is just, going to identify the image, or it will give you the probability, what is the probability of this image. If the probability is higher for animal, then it's an animal image, or if the probability is higher for building, then it's a building image, right? So I'm just going through. So if you want to learn more, and what that probability is about, how that is calculated, what is how the accuracy is calculated, or losses are being calculated, so please refer to my another website, which is styrisci.com. I had mentioned entire thing, like it's in pretty much detail. Or you can go to my blog as well, nextgenneuron.com, blog.nextgenneuron.com. So both the websites are maintained by me. Yeah, so coming back to the code. So I had mentioned how I had described, I had mentioned how I had constructed the CNN model here, right? So convolutional layer, max pooling layer, another pair of convolutional and max pooling layer, flatten layer, and that's it, right? This is a model. After that, I'm compiling the model using Adam optimizer. If you want to know more about optimizer, what is Adam optimizer and what are different optimizers available, please go through my website, styrisci.com, or yeah, blog.nextgenneuron.com. Loss is the cross entropy I have used, and yeah, so this will compile the model. This is this is fitting the training data and testing data here. This is the exact step where the training is happening for number of epochs I had mentioned, right? And finally everything is done, our model is ready, then it is going to be saved in the specific directory wherever I want. So I'm going to run this program. I'll show you how it happens. I'm just checking if there is any previous model I had already kept it. Yeah, there is no model, so it will be created here. So I'm going to run this program. Yeah, so you see, you can visualize how training is happening. You see, so it will take some time. Yep. So guys, CNN or any neural network application takes a little time. Yeah, it's loaded. So if you see, it's reading the directory structure. Yeah, identified two classes. Yeah, this training is happening. So it will go till 12. So it's the 12th one, and yes, this is accuracy loss graph generated. So if you see, the accuracy is supposed to go higher and loss is supposed to come down, right? So if it is going higher, it means it is yeah, it is learning more, and loss is going down means learning more and less mistakes, right? So this is the graph. So if you see the summary of this training, right? So in the first epoch, if you see, it it's showing some less accuracy, 0.52. Then again in the second round, it again showed some lesser accuracy with higher loss. Higher loss means less accuracy, loss means mistakes you can consider, right? Third round, it started improving itself. The model started learning more, So accuracy went higher again, like in the fourth round, it went to 0.88%. In the next round, 94%, right? And then it became fully accurate with loss is going relatively lower through each iterations, if you see, right? So this is the ideal state, like for each epoch or for each iteration, accuracy should go higher and loss should go lower, right? So after the last epoch, it's supposed to learn everything, and with lesser loss, and yeah, overall accuracy is this one, 80%. Yep. And after that I have saved my model to the directory. So now this is our model, the trained model, the CNN trained model. Okay, so here I have saved it. Now what I will show you, I will show you how it is classifying. So what I will do, I will provide another set of images which I showed you as a testing set, right? Testing data set. So I will present those set of images to this newly created model or classifier, right? CNN model, and we'll see how it identifies those unknown images. So this is a application for evaluation. So simply I have just, put all the required modules here, and here I'm just, trying to load the model from the directory where I have saved it, right? So it's loading the same CNN model from this directory where it got created. Image path, yeah, this is a test data image. As I showed you, this test data which was never seen by model through the training, right? So it's entirely new thing for it. So I'm loading the image set from here. Similarly, the class names I have mentioned, the folder names in animal and building, it will identify from these two names. I have, all the images I have standardized using the pixel 224 by 224, and processing those images to the model in a loop. It's going through the loop for both the directories, like going through each directory, going through all the images, and pushing it to model, and model will predict. So it runs. You see, it is just reading the image from the specified directory, and that image is being passed to the new model which I had created. This is an instance of new model, right? New model which I had loaded from here. So the image is being passed to that new model to predict, and here the model is predicting the class. Okay, so this is just code to predict the class. Definitely, guys, as I mentioned, so you just need to learn the programming, the Python programming, and some familiarity about these deep learning programming or machine learning programming if you want to have more grip on it, right? So but from this you can understand what's going on, what's the story about. So like it is predicting the class here at this step, and here we are printing the class with the confidence score, like how much confident the model was to predict the specific image, if it is animal or building. I'm going to run this. So if you see, yeah, so yeah, let's see how it does, how it performs. Yep, so may take little while. So yeah, so this is a model summary which I had, trained and kept it in the location. It's showing, yeah, it's showing its layered architecture or the learned parameters. Like these are the layers we had kept, right? So those got set there in the model. This is a model summary, and then it goes through the directory architecture, yeah, directory structure, and picks the image like from this animal building. It I had kept the building image as well, as I mentioned, to confuse the model. In the animal folder I had kept one building image as well, and it identifies it correctly as a building with 99% confidence. Let me show you this image. Okay, so in test data images, animal folder, so the first image is building, right? So it identifies at a build as a building. Okay, great. The second is chunky animals quiz. So what that image is, this one, this is some, some panda. So it identifies it as a building. It's wrong, right? So here it went wrong. Maybe not pretty good to identify panda. And third thing is the download one. This is also identified as a building. Guys, may not be accurate. You may need, some more enhanced images and more data to get much better results. But yeah, so here you can get an at least idea what's going on here. So yeah, so this identifies it as wrong, and the next one is download two. Download two. Yeah, so it identifies it correctly as an animal. Yeah, this was a correct prediction. Again, download 3 was also an animal. Again, a correct prediction. So, similarly, all those are correctly identified by the model, right? The last one, again, again, this download.jpg, download.jpg, this again identified wrongly as a building, right? So, okay, and this is a building set. This is a data set for building. If you see here, the first image was correctly identified as a building with 99% confidence, right? These all are building, right? So this one also building. Image1.jpg, image1.jpg is also identified as a building. Yeah, this one as well as building. This one is also building. Okay, so looks like buildings were identified correctly by model, but some of the gaps in animal. But yeah, it also did good prediction in animal section as well. Maybe if we do, the training of the model with some more layers and more data, so it will give more accurate results, right? So it all depends. It's an engineering, guys. How many layers you put in it, right? How you refine the data for training, or how you define the architecture of CNN to get the much optimized results or much accurate results, right? So this is how the training goes. This is a very small summary about yeah, coding demonstration about CNN neural networks. So yeah, so all the other neural networks, like the process is gonna be same. Like first we'll train the model and then we'll test the model. So this is for CNN, which is for images. We can have different natural language processing data models as well, right? The machine learning models or deep learning models, but the process is same. You just need to train the model. For example, for NLPs, you just need to train the model on some text data, right? For sentence prediction or machine or translation or question answering, whatever. I'll put more videos around those as well. And then the model does the prediction. So the process is same, guys. First we'll train the model on the data set, and then we'll test the model, and then we'll use the model for our use. Yeah. Thank you, guys. Yeah, that's it. And for more information and yeah, more articles, please stay tuned with my channel, as well as keep on reading the stuff on my websites, starishai.com, as well as on blog.nextgenneuron.com. Thank you.